Rain is a precious resource in some corners of the Earth where it never or rarely rains. Then there's Manchester, England, where the sun forgets to shine. Outside of Earth, rain being precious takes on a whole new meaning. In the far reaches of space, where planets like Neptune, Saturn, Jupiter, and Uranus hang out, these planets, unlike Earth, have a different atmosphere filled with an ungodly amount of methane. When it rains with thunderstorms, flashes of lightning burn the methane in the atmosphere, turning it to soot, which bonds with other spot particles to form clumps. These clumps continue to grow and harden, turning into chunks of graphite in the process. Since these chunks become too heavy to float, they fall under the gravity of these planets. The combination of atmospheric pressure and gravity compresses these graphite chunks into tiny diamonds, some of which can reach a centimeter in diameter. Saturn, for example, is the Manchester of space, experiencing loads of rainstorms annually. This results in diamond rain to the sum of 1,100 tons of shiny stones every year. So you're not broke, you're just on the wrong planet. Space launches are more expensive than you think. We mostly think about space launches in terms of sending people and important objects to space. What no one seems to question is if it costs anything or how much. Space is free, sure, but how much does it cost to get there? The answer? A crapload. The cost of a space launch depends on the cargo weight and several other critical factors. As of 2016, the expense of sending 1 pound of cargo to space is approximately $10,000. Currently, Elon Musk's SpaceX carriers cost approximately $27,000 per pound, whereas Orbital Science's Cygnus rockets set the organization back an eye-watering $43,180 per pound. To put it in perspective, sending a single lemon to space can cost up to $2,000. Meanwhile, a 16-ounce bottle of water could set you back anywhere from $9,100 to $43,180. You might want to leave your Stanley Cup behind. The sun doesn't burn. If you were asked to describe the sun, you might say it's a burning ball of gases. While that's partially correct, it's not entirely accurate. Yeah, take a moment to catch your breath for this one. We feel the sun's glare almost every day, and many of us have experienced sunburn from skipping sunscreen. Despite the intense heat, the sun doesn't incinerate gases. This is because burning requires a chemical reaction that rearranges the electrons in an atom. For instance, when wood burns, its atoms rearrange into charcoal. The substance remains the same, but its appearance changes. By that logic, if the sun were burning, it wouldn't remain the same. Instead, the sun, composed mostly of hydrogen and helium gases, undergoes nuclear fusion. In this process, atoms transform from one form to another rather than simply rearranging. So instead of burning hydrogen, the sun converts it into helium and heat energy. This process is so massive that it creates up to 300 million tons every minute. For perspective, that's like if we suddenly began blowing up 100 billion tons of dynamite per second. Also, for hydrogen to suddenly appear as helium, it has to be cooked under colossal pressure and heat. So the sun is really just an insanely large pressure cooker. If pressure cookers have the force of 250 billion of Earth's atmospheric pressure. That being said, while this galactic kitchen utensil might not be burning, we don't recommend booking a trip to it anytime soon. The beauty of Aurora Borealis, aka the Northern Lights. Green lights dancing in the sky have fascinated humans for decades, such that people make trips to see them or use them for romantic milestones. But what if we told you that even though it's a nighttime feature, the sun is actually behind it? You see, those mesmerizing green lights are formed by high-speed solar winds emanating from the sun. When these winds collide with Earth's magnetic field, some particles travel along the magnetic field lines straight to the geomagnetic poles. When that happens, these particles can no longer get out, so they begin to clash with the atoms in our atmosphere, which gives birth to light energy. So what we're seeing really is the color of different elements. Helium atoms glow blue, hydrogen purple, and oxygen gives the signature green and red. Interestingly, auroras don't exist on Earth alone and can also be found in even further away planets like Jupiter. The Hubble telescope caught an aurora on the gas giant in 2016. This is possible because Jupiter has an even stronger magnetic field, meaning its auroras are more vibrant and larger, covering more areas larger than Earth. Saturn is up there as well, with blue aurora ribbons near its poles. We are encased in a sphere. Scientists suggest that our solar system exists within a sphere made up of icy bodies. This spherical cloud exists outside the gravitational effects of the sun and sits anywhere between 2,000 and 100,000 astronomical units, AU, from the sun. This extremity is called the Oort cloud and is arguably the farthest distance from our sun. Given the space, the Oort cloud is mostly affected by the Milky Way's tidal forces, as well as those of stars passing by it. Unfortunately, since our best inventions cannot make such distances just yet, the Oort cloud is a hypothesis with no hard data. If all this space stuff is inspiring you, you might want to consider our partner for today, Course Careers. Are you looking to change or advance your careers seamlessly? Sign up with Course Careers today. It features courses in IT, accounting, data analytics, software development, and more, taught by experts in each respective field. No degree required. They also assist with job hunting to help you land the best positions. Simply click on the link in the description to get started today. The best part? They offer free mini courses to help you determine if the career and course are the right fit for you. It's time to skyrocket your finances. A Quiet Place, Infinity. While space is often described as a vacuum, it's not empty. In reality, space is teeming with debris, floating objects, and even life as we know it. Given all these different elements, you might imagine it's like a heavy metal concert up there. Comets whizzing by, planets colliding, satellites beeping, and that loud alien neighbor mowing the lawn at 4 a.m. But in truth, it's all very quiet up there. Sound travels through a medium, usually air. However, space lacks an atmosphere, so even if you scream as loud as you can, it won't be heard by anyone else in space. That's why astronauts use radios instead of gathering to talk. Radio waves travel electromagnetically and don't need air, making them ideal for the vacuum of space. Why so black? Ever wondered why space is so dark despite the sun being up there? Shouldn't it be blindingly bright? Instead, it looks like a moody emo goth child. Why is that? The answer lies in what is called Olbers' paradox, named after Heinrich Wilhelm Olbers, a German astronomer who suggested in 1823 that the universe is timeless, static, and infinite, so there ought to be a star everywhere you look. Olbers was onto something. The wrong idea. Because in reality, the universe is neither timeless nor static. If anything, it's expanding and in motion, as evidenced by the fact that the Milky Way is expected to collide with the Andromeda Galaxy at some point in the future. This means as the universe expands, the light from distant stars is stretched out and shifted into colors beyond the visible spectrum of humans. An astonishing sunset. In 2015, scientists' minds were blown by pictures of the sunset on Mars. Given the neighboring planet is often called the red planet, you'd half expect red or orange skies. Nothing could have prepared them for a blue sunset. What? How could that be? Well, on Earth, we have blue skies due to our atmosphere, which contains water molecules that scatter sunlight. Blue light, having the shortest wavelength, is scattered the most, making the sky appear blue. As the sun sets, its light travels through more of our atmosphere, scattering most of the blue light. This scattering leaves us with stunning hues of orange, red, and pink. But that's Earth. Mars is a different story. Its atmosphere is filled with iron oxide dust, not water molecules, giving the planet its red color. During the day, sunlight reflects off the iron oxide dust, making Mars appear orange or red. As the sun begins to set, the dense dust scatters the red light, allowing the shorter blue light to penetrate the sky. This creates one of the most stunning sunsets in space. The space junk crisis. One of Earth's biggest problems is trash. This issue has sparked discussions on carbon neutrality, sustainability, and eco-friendliness. While we seem to be making progress on the ground, the situation above us might be more concerning. That's right, we took our bad habits to space. Space junk has become such a problem that the next space race is for space cleaning. According to the Space Surveillance Network, SSN, there are about 23,000 objects larger than a softball casually floating above us every day. Recently, there has been a push for companies to develop methods to remove dead or damaged satellites and rocket parts from orbit, with the potential for significant profits. I mean, leaving our trash in space isn't much of an option. Many of these objects orbit the planet at 17,500 miles per hour, which is 10 times the speed of a bullet. This could make future space travel dangerous, if not impossible. Not to mention the potential damage to crucial satellites. Starlink, more like no link. Did you find these space facts fascinating? If so, don't forget to like and subscribe. Share this video with your friends and leave a comment with any other mind-blowing space facts you know.